Chapter 3. Now that we have the server installed and we have successfully connected with our client, we've installed some databases, now it's time to go ahead and start working with those. First thing we're going to start with is how to retrieve data from just a single table. And we're going to look at some of the methods. These are methods that you're going to use throughout. So this is really the start of everything right here. And it all comes down to this keyword right here, select. Remember, keywords are always expressed in all caps. That makes it easy to see. So anytime you see any kind of word that's presented here in all caps, that is a keyword. Select statements, that is going to tell the database what you want to extract from the table. So it's always a good idea to take a look at tables, and we'll do that. But understand the select statement's what we're going to use. We're also going to use some modifiers to the select statement, or different functions like concat, to kind of combine or concatenate different sets of data or different pieces of data. Most importantly, strings. And then we may also use the distinct keyword to only return distinct values to avoid duplicates. We're also going to use a keyword called where. That tells us where we are, or it's going to be used with comparison operators, so we might specify that we want to select something where a certain condition exists. Then we might use modifiers like in, between, and like, along with our where clauses to help make our where clauses even more specific. There's also the concept of null. Null means nothing, and sometimes we may want to just return conditions where a field is null. And so we might be using that. And then lastly, when we return our results in the results screen, we may want to sort them, and we'll use different order by clauses. So sounds like a lot, but we'll go ahead and get started. Remember, most of your statements that you're going to be using are going to start with select. You're going to select, and then you're going to specify what. And then you're going to add on a clause, a from clause, where you're going to specify from which table. Now you can get by with a lot of queries just with select and from. But if you want to return a specific set of data based on certain conditions, that's where we will add in the where clause. And then the order clause will sort that, and then we might add in a last limit clause to limit it to a certain number. So maybe if you've got a database with millions of sets of records in it, perhaps you don't want to return millions, you just want to limit it to 100 rows or something like that. So main ones, the 5 main clauses of the select statement, select and from, these are required. Select and from are required, so star those. Now where, order by, and limit, these are all optional. So let's look at some examples. If we select star, that's the star symbol. Star is a wildcard. That's going to select everything from the invoices table. And we know it's a table by a couple of things. One, it's all in lowercase, and it's plural. So the invoices table, and this falls along with the example databases that are provided with the books, so you can definitely practice these on your own in your MySQL workbench. But if we select star from invoices, it's going to return 114 rows. Now here, this graphic is only showing us the first 3. And we didn't specify any individual columns or fields, so it returns everything. We could, instead of saying everything, add in, instead of star, we could select the specific fields or columns that we're interested in. In this case, we just want the invoice number, the invoice date, and the invoice total from the invoices table. And here we're sorting them in descending order by the invoice total. So we can see this is the largest invoice, next largest, and so on. So this is very common to specify the fields, and you can tell they're fields because they're single, singular, they're not plural, and we separate that with a comma and a space to make it easier to read. Also, I want you to notice that it's a very nice format to start every clause on a new line. That way we can see, well, that's our select clause, that's our from, and that's our order by. Makes it real easy to see. Now, besides just returning static data, we can actually do a little bit of math with it if the fields are numerical. And so here you can see a great example of a select statement where it's continued on a second line and tabbed in. So it's you can see here that the second line starts right underneath the fields on the first. So this looks very easy to read. It's a good format to follow. So here we're selecting not only the invoice ID and total, we are creating a temporary column in our results called total credits, and we use the as keyword, capital AS, to create that, and what goes into that is the field credit total and payment total. We add these together, and the sum of these will be reflected as the total credits. And then we add in the from table. And then here we're specifying we only want invoice ID 17. So here it's only going to return that one invoice item, invoice ID 17. And here, instead of returning just the credit total and payment total in separate columns, we're actually adding these together and summarizing those in a new temporary column here. Now, this does not modify the invoices table at all. Select statements do not modify data. It just extracts data and presents it in a view or a results view for the user. It's important to know that this total does not get added in to the invoices table at all. It's just there for the results. Now here's one that's going to retrieve all invoices between given dates. So we're adding some more modifiers here. So we select our data items that we want. We want the invoice number, the invoice date, the invoice total from the invoices table, but we only want where the invoice date is between, and you can see here we're putting a date in single quotes, and then we're using the AND keyword. It has to satisfy and be between this date and this date. And then it's ordered by invoice date. And you can see the invoice date here. It looks like it's going in ascending order where it's going from the earliest to the latest. And this would actually return 37 rows. We're only seeing the first 3 here. Here's one where we want the empty, it's returning an empty result set in this case. Not necessarily we want one. Here we are selecting invoice number, date, total, and we want to return only invoice totals that are greater than 50,000 where we don't have any. So here it executes properly, but it doesn't return anything, or it returns an empty set. And so this is still a valid query, and it just doesn't happen to return anything. This I want to point out is different than is null. We'll get into is null later. Remember, select star, that's going to select everything, and then if you specify field names or columns, that will return those specific fields. And you can do mathematics with it. We saw an example of that. Here's one where we're using the concat, and here we're going to select the first name and last name, and we're going to save that as a new temporary column called full name. But to create that, instead of doing math with string data like a name, here we're going to go ahead and use the concat function. It's important with functions that you understand parameters. And in here, concat uses these parentheses. And we see here that our first parameter that's fed into the concat function is the field name, first name. Then we put in a set of empty quotes. That's to give it a space in between first name and the last name field. And so it's very important, and there is no space here between the T and the parentheses. These are connected. There's no space. I know it's kind of hard to see, but there's no space there. And so we're going to select and we're going to concat the first name and last name and put a little space in between it, and we're going to put that in a new temporary column name, full name. And remember, this temporary column is only on the results. It doesn't modify the table at all. So here's another example. This one, we're selecting invoice number, and instead of having invoice number here displayed, which you can see lowercase invoice underscore number, that's not very user friendly. This is how we name the field names in the table. But if we want it to display really nice for like a report or something like that, we can always use the as keyword to change the column name whatever we want, and we just enclose that in double quotes. And then instead of invoice date, we display it as date, and then you can see invoice total we're going to display as total. Now note that this one doesn't have quotes around it, or this one doesn't either. You could add these optionally and that'll work. There's really no need to unless there are more than one word in there. See here, if we didn't use the quotes and we tried to do invoice number, it's only going to save it as invoice. It's going to actually not even know what to do with that. So that's why you use the quotes around it. So it could be a good practice to go ahead and put the double quotes around it all the time, or not. Just understand if you use more than one word, you have to qualify it with double quotes. Here's a select statement. With a calculated column, it just doesn't name it, so you can see how that looks. It actually puts in the actual formula here. That's pretty ugly, so it would probably be better to go ahead and maybe add in an as total or something like that. So arithmetic operators you can use in your query statements. Now the star here, that's the same wildcard we used with select star, or selecting all from a table. But understand that if it's being used in a mathematical operator here, that it will be interpreted as multiplication. There's division. There's integer division, so on that, if you're only dividing whole numbers, you could just do div, but you could use that as well and it would work just as fine. Then there's the modulo. The modulo, if you've taken programming before, you're probably familiar with this, and what that does is it only returns on a division operation, it only returns the remainder. And that can be helpful for things like trying to identify if a number is odd or even, things like that. Rarely used in SQL, but it is available. And then you can see addition and subtraction. And more importantly, the order of precedence. So these will be executed first, and addition and subtraction would be executed after these operations, unless you use parentheses. And here, if we did 1 plus 1, and let's say we did 3 times that, well, this would be executed before that because we've set it off in parentheses. And here's an example. This type of example with the balance due is used a lot in different examples throughout the book. Here we're selecting an invoice total, a payment total, a credit total, invoice total, credit total, and then we're selecting the invoice total. We're subtracting the payment total, we're subtracting that. So you can see here, we're selecting the items up here, and then down here, we want to use math to calculate whether or not the invoice has a balance due by adding in those and then specifying it as a new column here. And all of this is from the invoices table. Very common operation that you'll see, and this is a way that you can do calculations based on data that's stored in a table. Once again, here's the parentheses to control the sequence of operations. Much like I pointed out before, it follows pretty standard math. Parentheses will be done first. So usually anytime you've got a formula like that, it's better to go ahead and parentheses these. Even though you think you might have your order of operations all sequenced out properly, it's always a better idea to use parentheses whenever possible, just to make sure. Here's an example of using the div and modulo operators. Just once again doing more math on it. Main thing is you're selecting the field you want to work with, and then you are doing the mathematical operation, adding the optional as clause so you can rename the column, and then lastly you have to identify from what table you are pulling that. And we're only pulling data from single tables right now. In later chapters we're going to be pulling from multiple tables, but this is the pattern to get familiar with right now. All right, so concatenate. We talked a little bit before with the first name, last name example. So concat is that function where we'll take different parameters. Here we're taking a couple of strings or one string and adding something miscellaneous to it. And this is a very common one that you'll be working with when you want to output combined bits of string data. So here you can see we're selecting the vendor city, the vendor state, and then we're concatenating these together to produce one output, Madison WI. Now notice that when we concatenate, it didn't introduce any spaces. So what we could do in here is we could add in some empty double quotes, and what that would do is that would put in a space. We could also put in a comma, and that could put in a comma and a space. We could do anything. We could even put in some other text, and it will concatenate it and add it in there. So very handy tool to use when you want to kind of format your results and be more user-friendly. Here's another example where they did concat. They added in some spacing and some commas, and then they added the as keyword to give it a nice column title of address. And there's just some more examples. Here they're concatenating right there in the select. So you don't have to select and then concat. You can mix in and do the concat right there with the select. That works as well too. All right, so we've talked about functions, things like concat, parameters. That's going to be what goes into the function. So parameters are usually contained within parentheses like that. And the parameter and argument, essentially the same thing. And then concatenate we use with strings, also known as text, or in MySQL language, typically these will be columns that are identified with something like varchar or char or char, however you want to pronounce that. That stands for variable character or character, and that's usually how string data is stored in the table, is as a varchar or char. Now there are other functions that you might use from time to time. Know that they're out there. There's dozens of different functions. If you Google MySQL functions, you'll see a list, and there could be some handy tools in there to make your life as a DBA, database administrator, much easier. One of these is the left function, where we're doing the left, and the input parameters that go into that would be the string and then the number of characters that we want returned. So let's look at an example in action. Here we want to select the vendor contact first name. So that's the name of a column. You can see that here. Then we want to get the last name from the vendor contact. And then what we're going to do is we're going to concatenate, and here this is kind of an advanced option. We don't necessarily need to concat to use left, but here we are nesting one function within another. So here we've got the left function with its input parameters inside another function, that's the concat, where basically it's going to concatenate the first character of the vendor contact first name, and then it's going to concatenate the first character of the vendor contact last name. So the first name and the last name is going to take the first character of each one of those fields. It's going to concatenate them together and store them, or display them, I should say, in the column known as initials, and we can see that here. So left vendor contact first name, 1, took that. Left vendor contact last name, took that. And then we concatenate them together, and you've got those results. Now, that's left. if you look out on the internet, you'll find that there is a right function, and if we did this with right instead of left, I think you could figure out it would take the last letters, and so this would actually be OO, lowercase o. But nobody really goes by the last letter for initials. It's usually first ones. There are a lot of functions that deal with dates and times. Very handy, especially if you want to calculate or do math in between different dates and times. These functions can be great lifesavers. So some of the initial ones you'll be working with dates would be the date underscore format. Once again, I want to emphasize this is all caps. It's a keyword. And then any function has input arguments or parameters that are in parentheses. And this is what goes where, separated by the comma. So let's look at it in action. Here we're going to select invoice date. Then we're going to apply the date format function onto that invoice date. And then here in single quotes is the format string. And you can see that it's going to format that date in this format here, which is commonly used. Or you may want to format the date in a different format. And you can do that with these modifiers here. These symbols, this percentage sign and letter slash, these are certain symbols that go along with the date format function to tell the system how to output or display or format the data. And so these are format codes, and there's different format codes that can be used. And if you do a Google on MySQL date format, you can see all kinds of different options you have there. And then you can manipulate these however you want. In certain countries, they like to say the day, then the month, then the year. And you can manipulate that however you want. A round function is available. Here's an example of the round function where it's going to round to the nearest dollar or nearest dime. You can see some examples here where it just rounded to the nearest dollar. This one rounded to the nearest dime. And the way it did that with the number of decimal places. This one is going to do a calculation. And so here, if it's going to do some, well, this one is not really a real-world application. You're never going to just do a select and put in some math. But what this is you can actually put in some numbers and have it output to your results. It's not really querying data. This is more for if you're coming up with a calculation, you want to do some kind of an initial test to make sure everything works, you can do that. Just be aware that all this is really demonstrating is the fact that you don't need to actually pull data from the database to use a select statement. You can give it values and it will function. Not useful in the real world unless you're doing some kind of development and need to test some things. Here's more examples of the concatenate function. Here we're selecting Ed as first name. So this is another example where we're not querying data, so we don't need a from statement. Here we're supplying Ed as the first name and Williams as the last name. So you can do that as well. Not very common, but understand that the power you do have with the SQL language, you're not reliant just on data from the tables. You can provide it static values as well with your, just like this with the select statement. Current date is a function where you can actually pull the current date according to the server, what its date format is and how it's what time zone it's in. Here's another example where it's doing some rounding, and once again the value is being fed to it. This select statement, select vendor city, vendor state, from vendors, order by vendor city. It's going to return 122 rows. You could limit this with a where statement and say, well, I only want where vendor state equals CA. You could also limit it with a limit clause where you only limit it to, let's say, 2, 3, 4, 5, 6, 7 rows. To eliminate duplicate rows, you can add in the distinct keyword. And so that way, it's only going to select distinct. So here, if you had, like the last example, we had vendors, vendors that were in Anaheim, so in Boston. So we had multiple vendors that happened to be in Anaheim and multiple vendors that happen to also share Boston as their location. Well, instead of getting all that redundant data, we could add in the distinct value, or I should say distinct keyword, and that will eliminate duplicates. The where clause, that's going to be different conditions that are evident. So different condition operators: equals, less than, greater than, less than or equal to, not equal, or I'm sorry, not within or not between, I should say. And then not equal to, that's a big one. The not equal, the exclamation equal is not equal, and this is not in, not between. So let's look at some examples where vendor state equals Iowa, so it's only going to return vendors states that happen to be in Iowa. If there are balance due invoices, we've got some examples here where we're applying some math. Vendors with names from A to L, so we're just doing where vendor name less than M. This is very efficient because, well, we know that if it's from A to L, that's the first, and L is there. Less than M is a very efficient way to write it rather than trying to do a long between A and greater than A, or greater than equal to A and greater than equal to L. We could just easily summarize it with less than M. Invoices on or before, so that's where we could use the less than or equal. So we can use these mathematical or comparison operators not just with numbers, but we can use it with string data as well, or even date data. And this is where well, doesn't equal 0, so you've got that, so it's not between or not equal. You can also use a not modifier in there. So not, probably not the best way. You don't want to always do double negatives. Watch out for that. But you could do a where not something exists. Not very common. Typically, you always want to express things positively, but you could see, like if you wanted to return all of the vendors except those in California, you could do where not vendor state equals CA. Rather than trying to list all of the other 49 states, it might be easier and more efficient than that. Overall, the main thing to keep in mind is you want to be, try to be ingenuitive with your queries, and if you can write it more efficiently, that's the way you want to go. You want to strive for simplicity here. So here's some other not operators where not invoice total is greater than or equal to 50 or 5,000, or invoice date is not less than or equal to that. So here it's important because either one of these conditions, if it's met, will return data. That's different than here where we need both conditions to return in order to return the data. Now there is an order of precedence if you're doing a compound conditional with not, and, or. Not will be executed first, then and, then or. I will tell you that this is one of the tricky exam questions, so if you've gotten this far in my lecture, maybe try to remember NAO, come up with some kind of mnemonic or acronym or something, but the order of precedence for compound conditions, not, and, or. Just try to remember come up with something to help you memorize that. And then there's some more examples of compound conditions. Remember, anything in the parentheses will be executed first. So here we can see this condition will be executed first, and then the results, the mathematics is applied on this. All right. Here's where you can use the where and the in keyword. So we can actually search to see if something exists in a set. Now here there is a space between the in and the parentheses. In is not a function, it's just a keyword or a modifier. So here we're saying where vendor state is not in these three. And we'll be getting into subqueries later. Just understand that you can use the where and you can provide it static values to have it search or not search. You can also use the between, so you could pull some data elements from the tables and see if something is between one or the other. So here we can see if the invoice date is between certain dates. The like is very powerful. The like can be used and provides some fuzzy logic on your returns. So this is where we might want to look for a match expression and either not like the pattern that we're comparing it against or like the pattern. And this is where we can use things like the percentage sign as a wildcard symbol or the underscore. Let's look at some examples. So if we used a where clause where vendor city is like, and then you can put in single quotes SAN, capitalized, that's important, there's a distinction, and that's how you want to express it, but we've got it in single quotes. And then you've got the wildcard, it's going to look for everything that starts with SAN. So we can see here San Diego and also Santa Ana. Another way we can look at it is here, if we look at example 2, where vendor name like compu, and then we have underscore ER, and what that does is that will look for things that begin with compu, but then also have one or more characters in between, and then the characters ER, and then any number of characters after that represented by this percentage symbol. And so we can see some examples here like compu serve and compu or computer world. Very powerful when you're really mining data. We won't be using these too much through our examples, but it's good to be aware of these like operators because it can be very powerful, especially when you're dealing with millions and millions of records and very large data sets. Now it brings us up into regular expressions or regex, and we're not going to use regex too much, but it's a more powerful type of way to fine-tune and surgically mine data. And there are special characters that are used in here. Just be aware when you see things like the caret, the dollar sign, the dot, car list, or comparisons of characters, or the pipe symbol. You can use some regular expressions in your queries. We're not going to be doing any of that in our examples, but it's here you can see if you're familiar with regular expressions and how to build them. Here we're looking at things that start with SA. Here, this regular expression of just SA at the top, that's going to look for any occurrence of the letter SA within a string. Here with the caret, that's going to start that. And then here you can see NA, that's going to be anything that ends with NA, not just has NA in it. And there's other ways to work with regular expressions. Like I said, that's going to be used with very large data sets. We're not going to be working too much with regular expressions. There's a whole science behind regular expressions, and there's lots of builders out there. Know that you can build your queries and add in regular expression clauses to your where clauses. Is null, though. Is null is one we will use. Null is not zero. Null is just an empty set of data. So here there might be some times where we are looking for something where something is or is not null. So here's an example. We're going to select star from null sample. So we're selecting everything from the table called null sample. And so here we're not really using the null keyword, notice there's a difference. Null underscore sample, that means this sample data table here. But a null component in it is identified here with the word null. This is different than 0. So here, that maybe this was a calculated amount and didn't have enough data to calculate, so it's showing up as null. Where this one, perhaps it had the data and it could calculate and it came up as 0, like this one or this one. So the main thing to understand here is null is an empty set of data. It's not the same as 0. So if we looked at that table that we just looked at, and here we specified where invoice total equals 0, it actually does return things. If we did where invoice total is null, it would return invoice ID 3. And here's another one where we're selecting star from null sample where invoice total is not equal to 0. Here's one where the invoice total is null, and here it is. It's returning that null. So that's the main thing to understand with the is null. Now you can use the is not null, and it's going to return anything that's got a value in it. And here you can see the zeros are identified as a value, even though they don't have any kind of integer value or decimal value, but it does have a data value. All right. The order by, that's going to sort things, and you can either sort ascending or descending. The default is underlined here, so when you read help documents and you see things like this, the underline infers that that is the default value. You can specify DESC, and you can change that. But here we're just simply selecting vendor name, vendor city, vendor state. We're concatenating these two and zip code into one column that we're going to call address, and we're pulling it from the vendors table, and then we're going to order it by vendor name, and it's going to be in ascending order. So our vendor name here is A, and you can see here that comes before that, before that. All right. And nothing really new on that one. You can do sorts by more than one column here. We're going to sort by vendor state first, then vendor city, then vendor name. So in this example, you can see Arizona becomes before California. So this might be handy if you want to do something like that and not just rely on the first column here. Now an alias. An alias is basically when we use that as term. Here we're selecting, we're concatenating that, and we want to display it as address. Address is considered our alias in this case right here. So here we're going to order it by address, then vendor name. So it's going to, here we can refer to this instead of the individual table column names. We can just refer to the alias, and in this case it's just going to take the first character of that container or whatever is held in that alias. Now the limit clause, besides just limiting the number of results, you can actually specify where you want to start, or the offset. And there are a couple of parameters that go into that. And here you can see that if we select the invoice ID, vendor ID, invoice total from invoices, we order it by that. If we use limit 2, 3, and actually typically you'll see that with the parentheses, either or. What that does is that's going to start or offset the first 2 records and basically display the third, and it will give you 3 results from that. So here we're not starting to display the second record, we're actually going to be displaying the first record after that. So that gets a bit confusing. And then the second set or second parameter here, that's going to be how many are returned. Another example of this is if we're limiting 100, 1,000, the first is the offset, so we ignore the first 100 rows, and then we return 1,000 after that, or up to 1,000. Here there happen to only be 14. But it's important distinction on that when you see limit with two parameters there. Now if you just did a limit 100 or limit 1000, then it's just going to go ahead and return the total without the offset. That's all for this chapter. If you got any questions, as usual, post them out on Slack. Look forward to talking to you again.